Alright, 9-1. Talking about the image that you get after you translate something. So let's kind of go through part of our note-taking guide to make sure we get this. Graph the quadrilateral ABCD with vertices that are there. Find the image. That means after the translation, that's your image. And we use notations of prime. So here you see a prime on the A, and it's kind of like an apostrophe. That's what it looks like.
Yeah.
You can just put a 1, a little 1 beside it like an exponent. That's what we're talking about.
Haven't we done these already?
We've done stuff like this in algebra. You guys totally get this. But this is gonna lead to something else, vectors, and understanding what vectors are, and then using matrices to do translations. That's tomorrow. Okay, so tomorrow's an e-learning day probably.
Do you think we'll get canceled?
Yeah, so what you're going to do is you're going to get on Google Classroom. If you haven't downloaded that and got on, that's your own fault. You have the codes up there forever. Get it taken care of. If you don't have internet access at home, you need to get on there before you leave today and download the video. At the end of the video is your assignment. So then you just bring it back to me when we go to school. You don't have to give it to me on the classroom. Okay?
When's it due? Because people are saying it's due different days.
It has to do Monday.
Alright.
But you're gonna do it and bring it to me Friday, right?
Are we going on third?
Tomorrow's Thursday.
Oh.
If you are here at school tomorrow, bring your earplugs, and you're going to listen to the video and do the assignment tomorrow, just as if you had an e-learning day.
Sweet.
Okay, moving on. All right, so watch what happens. We're translating this by 3. What does this mean? How do I move each of these points? Garrett.
You take your coordinate for the first one, like for A. You add 3 to the x, and then you subtract 3 from the y.
All right, so what is A prime going to be?
1.
1, 3.
Oh my gosh.
1, 3. So at 1, 3, that is A prime. That's how you graph it. What?
I just spilled a ton of water.
Oh my god.
Can I get like towels or something?
Yeah, whatever.
You need more than a towel.
Dude, I thought there was a cat.
Napoli, what's B prime?
Negative.
What is 2 plus 3?
Oh. 5.
And what is 4
1.
minus 3?
Sorry.
1, 2, 3, 4, 5, and 1. There's B prime. Alright. 2, 1. What do I get
5.
there? Mason.
5. Negative 2.
5, negative 2. That's C prime. And D prime meant the other Mason. 1, 0. There's D prime. Now, on your homework, if it says to draw both, you draw both. Okay? But make sure you have your primes on there. I want to know what the pre-image is. That's the image you start with. And the image. I want to know that just by looking at stuff. If it tells you to graph both, then you better graph both. Alright, so here, example 2 is write a rule. The rule, this is a rule right here. That's the rule for the first one. So you're just describing your translation. Here's A and here's A prime. All you got to do is look at one set. You don't need to look at every one. What happened from A to A prime?
Plus 3 minus 2.
From
Or,
here
okay, never
to
mind.
there.
Never mind. It's plus 2 minus 3.
Your X value, did you go left or right?
Left.
So that means minus.
Oh.
What is A? What's the coordinate on A?
3, 2.
Okay, thank you. 3, 2. What's the coordinate on A prime?
0, 4.
What happened to A? X value.
X minus 3 plus 2.
You subtracted 3. And on Y, what did you do? You went up 2.
That's what I said.
There is your rule. Anybody confused about how to write a rule? It should look just like this. Got it?
Yep.
All right,
See,
we've done this
smooth.
before. It's not. This isn't anything crazy, okay? All right, let's go to theorem, translation theorem. Translation is an isometry. Okay, basically, all the rules have the same slopes of what's going on, right?
Right.
Okay. All right, checkpoint. Everybody do this. Draw PQR. Draw PQR and draw the image. There's PQR. Everybody be down here.
Yep. Yep.
What's it called?
Okay, any problems with how to graph the image? Any problems with how to write a rule?
Are the things the same? Like, are they the same size and stuff?
Yeah.
That'd be a dilation.
Translation.
Translation,
They just look a lot.
Yeah,
Shape and size
the
is the same
second
thing.
one looks bigger.
Yeah.
I think it's supposed to be down.
No, the second one was
Ours.
smaller.
The second
oh,
one's
that
smaller.
one, sorry.
Yeah, that's why I asked. I just wanted to
Right here, up. I went up too, thank you. That looks better. Awesome. No problems with writing a rule, no problems with graphing the image.
Nope. None. Seniors.
You're all gonna tell me what isometry means tomorrow. Vectors, here we go. Here we go, Victor. Okay, vectors. The diagram shows a vector named FG, read as vector FG, okay? The initial point or starting point of the vector is right here. Is, if this is 0, 0, okay, what is it?
2, 2.
2, 2. So we'll say F, is it 2, 2? Doesn't really say where it's at. Terminal point or ending point of the vector is G or 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, right? The reason I'm-
Seven.
Seven.
1, 2, 3, 4, 5, 6, 7. Thank you. 7, 5. The reason I'm writing it like this is I'm going to show you how to come up with a vector. A vector is really just slope, but it's not written in slope form. Slope is written as the change in y or the change in x. Vector is really the change in x here and the change in y there with that notation, not parentheses, but this is vector notation. Okay? So the change in x goes here. What's the change in x? Here it says 5 units. How could I figure that out? 7 minus 2. That's how we actually find vectors. You take the ending point of your ray, your vector, minus the beginning point. And that's what gives you your x value. So 7 minus 2 is 5. 5 minus 2 is 3. So that's what these are right there. The vector is 5, 3. Vector FG is 5, 3.
Is the vector like a point?
So it doesn't matter where the vector's starting from. Okay, what'd you say?
Is the vector a point or like what is it?
It's a ray.
Oh.
It's a ray.
Ooh.
Gives me distance as well. 25 and 9 is 34. The square root of 34 would actually be that distance. Isn't that what you found out? x2 minus x1, y2 minus y1, and that how you find slope as well. You got slope and distance
Yeah.
formula in here. So if I wanted to know the distance, this is pre-calculus here. You could just square both of those, take the square root.
What did you mean the end of the line?
Well, a vector is like a ray. It has a starting point, and then it has an arrow to the ending point. A ray really goes on forever. But a vector goes from one point to the next. But the point of the arrow is to show you that this is where you ended up. Instead of just showing you a segment, the arrow shows you where you ended up, okay? Alright, so enough of that. That's what a vector is. Let's answer this other question here. The component form of a vector combines the horizontal and vertical components. That's what we just did. So this was F, this was G, and this is our 5 and our 3. That's component form. That's what that's called.
So if they told you to find vector GF, would it be the same thing? Or would it be like negative?
This is what it would look like. Then you would take this value, which was what, 2, 2, and this was what, 7, 7, 5. You'd go 2 minus the 7 would give you the negative 5, and 2 minus 5 would be negative 3.
Okay.
Okay? Opposite direction. Alright. That was above and beyond what you needed for this.
Can we draw it more people regularly?
Yes. Yes. And the vector in its component form. So the vector is what? GH. Component form is what? Again, you're doing your x change. What's the change in x from here to here? Okay, it's 5.
Negative 2.
Going down.
Nice.
So if you're going left, the x is negative, right? If you're going down, the y is negative, right?
Yep.
Yeah, okay. So you don't need an x and y axis, but a lot of times you're going to have an x and y axis, or you're going to have polar equations, polar forms. Fine to do that. All right, this one.
Negative 7, 0.
So you're going left, negative 7, 0. Doesn't go up or down. So that's your vector. Any problems with vectors?
Nope.
Okay. Vectors are really translation rules. Going from one point to the other point. That's the abstract behind this. Using vectors to translate points. Okay? Moving on.
Sí, señor.
That's good enough.
I'm gonna tell you what time it
Here's your assignment.
is. I know, isn't that dope?
We're gonna do page 576. 3 to 29 odds. Begin.